Hello, today I want to have a look at this little phono preamplifier. The point of an amplifier like this is goes from between your turntable and your normal amplifier. Most amplifiers these days do not have a phono stage built in. However, older amplifiers from before year 2000 and back, most of them will have a built-in phono stage. However, new amplifiers, most of them won't have it. So this is a fairly cheap little phono amplifier. It's called N Audio. The model number is PP400. I believe it's the same that is sold under the Behringer brand. They just charge a little bit more for it, but it's the same model number and everything. This one you can get it online. You can buy it for like around $20 or something, either on eBay, AliExpress, or your favorite place to buy things. It's a nice little compact unit. It comes with a power supply. It's a switch mode, and it will take 50-60 Hertz, 100 volts up to 240 volts or something like that. So it should be working anywhere in the world. We can see the input here is 12 volt DC, and then we have the input here. This is the one that goes to your turntable, and the output here will go to an input on your amplifier before going to your speakers. However, while this seems like a nice little budget solution, I did some measurements on this in my previous video, and I found out the frequency response is not that great looking. So I would like to have a look at, see if we can improve the performance of this little unit here, so we can get much better sound quality out of it. So let me take it apart here, and then we'll take it from there. Okay, there we go. The lid comes off. So it's a nice metal case. No problems there. Small board in here. Let's get it out. That's it. Everything is on one single board here. Get the screws over here before they disappear. It looks like we have a number of coupling capacitors here, so clearly, I mean, we have the power coming in here, we have some smoothing capacitors, I would assume. Since it's a single 12 volt input, I suspect it's going to be like a virtual ground kind of thing. And we can see we got a single op amp here, well, it's dual op amp, the two op amps from this one, but each channel is done with a single op amp. And we have some capacitors here, probably for the equalization. So what I'm going to have to do now is to create a schematic based on the circuit board here, so we can better understand how is this configured and how can we improve it. Here we can see the top side, and it's quite nice. So it's got like a huge ground plane on both sides. And they even put on the component values here. Microfarad, 50 volts, 47 microfarad, 16 volts. What's that? 820 picofarad, 3.3 nanofarad. It looks quite nice. See the other side here. Right. So here we have the power coming in. Looks like a reverse protection diode. We have some resistors and stuff, and over to the LED, and here we have the op amp. So it's quite interesting. That's a JRC part, so that kind of indicates it's a it's a Japanese design, because that's like Japanese Radio Corporation. You usually don't see those used in designs outside of Japan. It's a 4580, the op amp, and we got various resistors and stuff here. So let me just take the time. I will sketch this out in a schematic, and then we can have a closer look at what is going on, and maybe have a look at what can we do to improve the performance of this this little phono preamplifier. Okay, so I'm back here. I have created a schematic for the whole phono preamp, and this is what the power supply section looks like. So we have 12 volt coming in here. We have a reverse polarity protection diode, and then we have some capacitors, and we have a voltage splitter here with these two 22K resistors, just to create the virtual ground voltage. It will be like 12 volt here, 6 volt here, and then 0 volt here. But as everything is relative, we can just say this is 0 volt, and this becomes minus 6 volt, and this becomes plus 6 volt. So that's how that's going to work. Take a look at the actual amplifier circuit. Get into focus here. There we go. So yeah, it's very simple. There's only one op amp per channel. So we have the input signal from the phono cartridge coming in here, goes through a capacitor, and then we have our 47 kilo ohm input impedance. The reason we need this capacitor here is because we're using the virtual ground as the reference for the signal. So it's going to be swinging around half the voltage, right? And then it just goes into the positive here on the op amp, and then we have all the equalization is being done in the feedback loop here, and we set the gain and everything here reference to ground, and then we have an output, quite a large coupling capacitor on the output. I assume that's because they designed it to work with, in a professional environment, you might use 600 ohm load impedance or input impedance. So that could be the reason they have really large capacitor here. In most home hi-fi amplifiers, you don't need that large of a capacitor, but it's not going to cause any harm. Anyway, I put all the values on here on what the original circuit looks like, and then I took the time to try to find some new component values. So let me just get this in focus here. So what we have here is a Spice model. So I'm using this software, LT Spice. It's free. You can download it online. It's quite nice for modeling. Just you should not always trust the Spice models. Sometimes you need to do real world circuits. But it gives some good guidelines, and it can be very nice for tuning circuits like this. So I made a few component changes in this modified version over here. The first change is that this resistor we have here, I've changed it from 2 kilo ohm down to 1 kilo ohm. So this kind of sets the gain of the whole circuit. So I would like the gain to be close to 40 dB. At 1 kilohertz, because that kind of makes good sense for most moving magnet phono cartridges. However, when I change this, we also need to change this capacitor, otherwise it's going to be rolling off too early in the low frequency. So this value you see here, 14.7 microfarad, is of course not a standard value, but the idea is just to add a 10 microfarad in parallel with the original 4.7 microfarad. So that should give us pretty good low frequency frequency response. Other than that, I've made some fine tuning of these three components here. So you see I changed the 3.3 nanofarad to 3 nanofarad. So 3 nanofarad is a standard value, and the same with 1 nanofarad. So from 820 picofarad to 1 nanofarad. And however, the resistor here is not a standard value, 78 kilo ohm from 100K down to 78K. I usually do it like this because it's more difficult to create capacitor values. It's easier to create resistor values. You can just put some in parallel and series, it all gets sorted out. But capacitors I like to stick to fairly standard values and something I actually have. So that's pretty much it, right? 1, 2, 3, 4, 5 components change here, and then the huge advantage of a SPICE model is that you can actually predict what it's going to perform like. So if we look here, this is the performance of the original circuit, and you see that looks very similar to the actual measurement I did of the amplifier. So there's almost like a 3 dB difference between the low here and the high, and you can definitely hear that. Everyone can hear that, especially if they get to listen to something that doesn't have this problem. So if you can switch between two amplifiers, one that's got this kind of equalization and one that's flat, then you can easily hear the difference. And here's the modified circuit, so you see that looks very nice, very flat. It doesn't get much better than that. Okay, so what I'm going to do next, so I'm going to try and modify the actual circuit, solder in the new components, and then we can try power it up and do a measurement and see if it corresponds with our simulation here. That would be quite interesting. So that's what's going to happen next. Okay, I completed modifying one of the channels. I hope you can see it here. So we changed these two capacitors here. So I didn't have a 3 nanofarad, but I did have a 2.7 nanofarad and a 300 picofarad. So I put those in parallel to make 3 nanofarad. And this 2 kilo ohm resistor here, I changed with a 1 kilo ohm. And under here is the 78 kilo ohm, so that became 82 kilo ohm in parallel with a 1.5 mega ohm. That gives close enough to 78 kilo ohms. And then the 10 microfarad in parallel with the original 4.7 microfarad. So it's not too bad. It's a little bit fiddly because they went with 603 resistors here, so it's quite small, but it's doable. Anyone can solder that. It really shouldn't be a problem. So I thought now it would be interesting. I only modified one side. I thought it would be interesting to do a measurement, and then we can do a direct comparison between the two channels and see if it's actually improved and what it looks like compared to each other. So I'm going to do that now. I'm just going to hook it up and then we'll do a measurement. Okay, so I got it hooked up here to do the calibration first. Let's do that. Run the calibration just to make sure we get any frequency linearity errors calibrated out of the circuit here. Okay, that's the calibration, and then we hook up our phono amplifier here, and take these cables here and just lower the level a little bit here, and I think that will be okay. Let's go with this. Okay, it looks like it's not clipping. It's pretty high output voltage, but it's not clipping. So we can definitely see a difference in gain here. And the red one up here is the modified channel, and the blue one down here is the original channel. So actually this looks very close to the simulation. It's got a little bit better frequency response in the high end than the simulation, but other than that it looks pretty much the same. We can try compare here. See, this was the simulation, right? They look fairly equal, and you can also see the gain has been raised, so it's like very close to 40 dB, whereas before it's around 35. We have from 32 up to 35, so that looks really good. So I think now I'm gonna complete the modification. I'll modify the other channel. I'll try and hook it up to my system and I'll have a listen to it and see if it sounds better. Okay, I have completed the modification of both channels now, and it's ready to reassemble, and then we can do a final test on it. However, I noticed, one thing I have noticed in the past was that normally when you connect your turntable to the inputs here, you will also have a ground connection or shield connection, and normally you will connect it to somewhere on the amplifier here, but there's nothing here. So I did notice there's like a screw here, so it seems like maybe someone intended to have something here to connect, but I mean it's not gonna work because it's full of paint. However, I found something here, so I do have like a small finger screw knob here. So I think if I screw this in here and just remove some of the paint, then I think that will make a reasonably good ground connection. So I'm just gonna go ahead and do that, and then I'll assemble this and we can do a final measurement, and then I'm gonna hook it up to my stereo and have a listen to it. Okay, so I fully assembled little phono preamp again, and this is the screw I installed for the ground shield connection. That seems to be working quite nicely. So I think we do a final measurement here and then see what the performance looks like now. Let's include the input impedance. I don't expect there to be any changes, but let's check it. There we go. Right channel, left. Yeah, it looks absolutely fine. Around 47 kilo ohms and 13 to 15 picofarad. So let's do the frequency response. That's really where the big changes are going to be happening. Let's hook it up here. Okay, let's connect it. Yeah, so let's run this, I think 20 millivolts. Let's try that. Frequency response. Yeah, it's looking good. That's a little bit of clipping on one of them here. Okay, it's probably a little bit too high. Let's try 15 millivolts. Okay, now there's no clipping. As you can see, it's very, very flat compared to what it was like before. And actually the two channels are really well matched. I didn't really put much effort into that, but it looks like they're within like 0.1 of a dB difference in gain across the whole spectrum here. So I would say that looks really great. And it's extremely flat down from the bass all the way up to the high treble, and then it starts rising a little bit, but even this rise is extremely small. So that kind of puts it into a whole different class of phono preamplifiers. I recommend, if you own one of these, you should make this modification. It's definitely worth it, and I think you'll be very happy you did it. And also, if you're looking for a phono preamplifier, you're on a budget and you're willing to put a little bit of work into modifying it, you could buy one of these. It's only $20 delivered, so not much can go wrong there. If you want to make more modifications, you could change the coupling capacitors. They're pretty low quality. The ones installed in here, it's electrolytic capacitors. It's fine, you can stick to electrolytic, but you should get some bipolar electrolytic, and maybe get something like, I have these Nichicon here. They're quite nice. They're bipolar capacitors, so if you can find some of these in the right values, it's only those 4 capacitors there. Put in some Nichicon bipolar. I didn't have the correct values, that's why I didn't do it. But that would probably be worth one upgrade. I wouldn't change the op amp or anything like that. I think it's fine, no problems there. Okay, I think that's it for this little phono preamplifier. So time to hook it up to my record player, and we're gonna have a listen to what it sounds like.